Greetings, statistics scholars, and welcome to this next in our series of videos on Chapter 2, Describing Data. In this video, we'll be taking a look at creating and interpreting box plots. I'm going to begin here, as we often do, with a data set. This is a data set that comes pre-packaged with your textbook. If you open up the StatKey app, you'll find a quantitative data set that gives flight times for flight number 433. And you can see here a dot plot of the 31 different times for this sample of flight times. Of course, we can use StatKey or any other bit of technology to help find the 5-number summary for this data set. Here's what StatKey shows. And you can see there near the bottom of the summary statistics our 5-number summary consisting of the minimum, the 3 quartiles, and the maximum. We'd like to take a look at a very useful way of visually depicting the quartiles of a data set like this one. And that is something that we call a box plot. A box plot gives a very nice way for visualizing the quartiles of a quantitative variable. How does it work? Well, we begin a box plot with a box in the center. Now, the left end of that box is drawn at the first quartile of the data set, Q1, and the right end of the box is drawn at the third quartile of the data set. What that means is that this box spans over the middle 50% of the variable's data, and the width of that box equals the interquartile range, the difference between Q3 and Q1. Now, we're not done totally with the box yet, because we're going to add one more thing to it. We've given the first quartile and the third quartile. We're also going to add the second quartile, which is the median. And that's going to be drawn as a vertical line inside of the box, wherever it might be. Now that we've got the general idea of how we create the box for a box plot by showing the quartiles, let's take a look at how we would begin the box plot for that flight 433 data set. The box plot is going to begin with that box that shows the values of the quartiles. We'll show our summary statistics again here for a reminder. Remember that 357 was the first quartile. So we're going to draw the left end of our box at 357. The right end of the box will go at the third quartile, which is 378.5. There we draw our vertical line at the right end. And then we're going to draw the box to join those two. So there we have the box for the box plot, but again, remember that we're going to mark the second quartile or the median. Here, that's 369. So we'll find where that is on our number line. And right at 369, we'll indicate where the median value is. Now, once we've done that, we've made a very significant portion of the box plot, but we haven't finished all of it, because a box plot, in addition to showing a box, also has some whiskers. Let's take a look at how to draw the whiskers of a box plot. The first key fact is that the left whisker of the box plot goes from the left end of the box down to the lowest data value that is not an outlier, while the right whisker goes from the right end of the box to the highest data value that is not an outlier. Now, if there are outliers in the data set, those are going to be specially marked on the box plot by a mark, usually a dot or an asterisk, at the locations of any of those outliers. If it turns out that there are no outliers in the data set, that's going to end up meaning that the whiskers are going to extend all the way down to the minimum value, in the case of the left whisker, and all the way up to the maximum in the case of the right whisker. Now for this data set that we were looking at, the flight times for flight 433, it can be shown that there are no outliers in this particular data set. Because of that, that means that our left whisker is going to extend all the way down to the minimum value of 346 minutes. And there we've shown our left whisker extending down to that value. Since there are no large outliers, that's going to mean that the right whisker is going to extend all the way up to the maximum value of 407. And there we've drawn that extending from the right end of the box out to 407. So by creating the box and then by adding the whiskers, we have finished our box plot. And here we have a picture of the resulting final plot as shown in StatKey. Now that we've learned how to create a box plot, let's do a little bit of practice interpreting a box plot. And these questions that we're going to look at are based off of a data set from StatKey. This is based off of the student survey data set, in particular looking at the variable on exercise hours. They asked students how many hours a week they tended to exercise on average. And you can see the box plot that was made of this variable. Let's ask some questions about this box plot and see if you can't answer them. First question we're going to ask based off of this box plot is, about 50% of all the students in the survey had at least this many exercise hours per week. What is the number of exercise hours that about 50% of the students had at least that many hours? Well, if we're talking about the value that had 50% of students more than it, it would also have 50% students lower than it. That would be, of course, our median value. And remember, in the box plot, that is the line that goes down somewhere inside of the box. And here we can see that that's right at about 8 hours. Since the median appears to be about 8 hours from our box plot, that is the answer to the question. About 50% of all the students had at least 8 hours exercising per week. Now for a second question, again by looking at the box plot, approximately what percentage of the students in this survey had 12 or fewer hours of exercise per week? Well, let's take a look at our scale and find where 12 hours is. It's right there. And we note that that's at the right end of the box in the box plot. Well, what is that place? Remember that the right end of the box marks the third quartile. So that gives us our answer. Since the box plot shows that Q3 has a value of 12, that means about 75%, or 3/4 of the students in the survey had 12 or fewer hours of exercise per week. Again, by understanding the meanings of those visualizations in the box plot, we can answer that question. A third question, were there any outliers for this data set? And if yes, how many are there? Well, looking at that box plot there, we can clearly see that we have some dots appearing there in addition to our box and our whiskers. We see them over there on the right-hand side. Those represent outliers. So definitely yes, there were certainly some outliers in this data set. And by counting them, we see that there were 9 outlying students altogether in the survey. What is the interquartile range for this data set? Remember, we said that the box in the box plot is designed to show the span of the middle 50% of the data. The box runs from Q1 to Q3. So if we ask how wide that box is, we'll have our interquartile range. From earlier, we remember that the third quartile was 12, and it's pretty clear that the first quartile is 5. So the difference between those two values, 12 minus 5, or 7 hours, is the interquartile range for that data set. Were you able to answer some or all of those questions? If so, that means you're well on your way to understanding the meaning of box plots. I'm going to finish up our presentation here with another example of making a box plot. And this comes from a data set from the Handbook of Small Data Sets. And this was a data set on the average amount of sulfur dioxide in the air for a sample of 41 American cities during the period between 1969 to 1971. And you can see the full data set there on the left-hand side. And then this is in micrograms per cubic meter. We've generated over on the right-hand side the summary statistics for this data set of size 41. You can see the mean and the standard deviation. Of course, you can also see the 5-number summary, including our quartiles. So those are going to become very important for us shortly in creating our box plot. One of the things we always have to consider when we're making a box plot is, are there any outliers? In this particular case, the interquartile range is 35 minus 13, or 22. We're going to review here on the next slide a way for determining if any of the data values in the set would be considered to be so small or so large that they are outliers. The method for doing that, as presented in the book, is by taking 1.5 times the interquartile range, subtracting it from Q1 and adding it to Q3 to get some values that we call the fences. Of course, Q1's value was 13. 1.5 times the interquartile range is 33. So 13 minus 33 is negative 20. That'll be a value that we call the lower fence. What that means is if any of our cities had lower than negative 20, they would be an outlier. Of course, none of our data values is less than 8, so we have no lower outliers here. On the upper side, to find how big something would have to be considered to be a large outlier, we add 1.5 times the interquartile range to the third quartile. Here the third quartile was 35. So if I add 33 to 35, I get 68. Now that upper fence does indeed have several cities that are larger than it. As a matter of fact, there are 3 of them. Philadelphia, which had a value of 69, Providence, which had a value of 94, and Chicago, which had a value of 110. All of those are larger than the upper fence of 68. So each one of them is considered to be an outlier. That's going to be significant for creating our box plot. We're going to mark those 3 outliers on the box plot with asterisks. That also means that when we make our right whisker, it has to stop at 65, which was Cleveland's value, for that is the largest data value in the data set that is not an outlier. It's the largest value that is less than 68. So let's put those facts together and create our box plot. In this case, we have a box plot that is going to show some outliers. Here's our quartiles, 13, 26, and 35. Of course, we'll use those to make our box. There's our box stretching from Q1 at 13 up to Q3 at 35. And you see we've marked the median at 26. That's always our first step. Then we draw our left whisker. There were no small outliers here, so that left whisker will extend down to the minimum value of 8. Now on the upper end though, we are not going to extend the right whisker all the way to the maximum value because we have 3 outliers. We're going to mark our three outliers at 69, 94, and 110. And then we're going to make sure that our right whisker stops at 65, which was the value of Cleveland, the largest data value that was not an outlier. So that's our procedure for creating a box plot when we have outliers that have been detected. I hope you found this video to be informative and helpful in understanding the idea of box plots.